Hey, what's up guys? Jeremy here from RoboDK. Welcome to yet another tutorial series covering our newest CAM plugin. This time, we created a fast and easy way to transfer machining programs from FeatureCAM to RoboDK. In this video, we will learn how to create this 3-axis machining project. The goal is to create this 3D wall panel from a stock of material. Some of our clients already use this method to create high-end decor, using the robots for wood or stone milling. This could also be used with some kind of foam to create molds for a material like concrete. Okay, let's start this project. We start our example with this RoboDK station. It uses a Motoman MH6S10 and a machining spindle. There's a table in front of the robot to precisely position your stock material. The finished part is at its position, right here. Right in the corner, there, you can see a reference frame. This reference frame will match the origin of the setup defined in FeatureCAM. Okay, let's jump to FeatureCAM. I already imported the part and created my setup. Make sure the origin of your machining setup matches the origin of the reference frame you wish to export the path to. Same position and orientation are required. I'm going to rely on the Automated Feature Recognition, or AFR, of FeatureCAM. This pretty much gives FeatureCAM the total control over the machining process. It may work for your project, or you may have to use the other very powerful tools available in this piece of software. My goal here is to show you how's the transition between FeatureCAM and RoboDK, not to show you how to use FeatureCAM. They have plenty of pretty detailed tutorials for that matter. Okay, now that we have the sections in between the shapes, let's do the tier shapes manually. We will use surface milling. We will select the surfaces. There's a few of those to select. Okay, like that. I'm going to limit myself to the finishing program here. I don't really need to do the roughing. So let's use 3D spiral. Okay, now finish. Now we can simulate this part of the project. Okay, now we have a machining project. Obviously, you may need to fine-tune the milling program, but for now, let's say that this is exactly what we need, okay? Now for the export to RoboDK, you have the add-ins tab. If the RoboDK plugin is installed, you should see this section here. You can take a look at our online documentation to find out how to access the plugin. For the first tutorial, we will concentrate on the Load and See Program option. It will simply load the milling program to RoboDK. But before using it, let's open the settings. A very important thing to do here, if you want to improve your workflow, is to enter the name of the reference frame representing the origin of the machining setup in RoboDK. So if we go back to the robotic station, I want to import my path in this reference frame here. Its name is machining, so let's copy that. Okay, back to FeatureCAM. Now paste the name in the reference frame text box. By default, the rest of the settings should be right. If you have more than one robot, you can enter the name of the right one here, and same for the tool here. Okay, let's start by simply selecting the surface milling. Let's forget the rest for now. Only the checked process will be exported to RoboDK. Now let's press Load and See Program. You will see this little window appear. You can then press OK to force FeatureCAM to recalculate the path and simulate it. That will also automatically force FeatureCAM to use the right post-processor for the export to RoboDK. If I have clicked cancel, it wouldn't have recalculated the path, which can save you a good amount of time in certain situations. Now we can go back to RoboDK. As you can see, considering that we indicated the reference frame in the settings of the plugin, the milling path was imported where we needed it. If you look at the station tree, you can see that a machining project was automatically created. Just like that, I can right-click the machining project and hide the tool path normals. This way, we can better see the path itself. You can also see that a new tool was automatically created. It's called Tool ID 1. I'll give you more detail on that in the next video. Let's open the robot machining project. Before doing anything else, I need to make sure that the right robot, right reference frame, and right tool are selected here. In this case, everything matches. It's a good thing. As you can see from the green check mark here, the program was automatically updated after the import and RoboDK found an achievable robot path for it. Therefore, we can simply press simulate to see the result. Okay, that looks good. Perfect. I can use the slider to scroll the program. Okay. Bring it a bit further. I can also go backward. That's great. Okay, now the goal here is not just to create a simulation. The goal is to generate a real robot program. So just underneath the robot machining project, you will find the linked program. If you run this one, you should see the same result as when you pressed simulate. Right-click on it. Now go to Generate Robot Program. After a few seconds, it will open this new window. In this window, and in the case of a milling project, you will find many programs. One is the main program. If you open it, you will simply see a bunch of program calls. This is because machining programs are generally quite big, so by default, we are splitting them in smaller files. The number of lines can be modified if needed. You will then find all the subprograms. Let's open one of them. In the case of a Motoman, the files have the JBI extension, and at the top of these programs, you can find all the positions to reach. If we go down, quite a bit down in fact, we will find the move commands related to the position we've seen at the top. So this program is ready to be transferred to the robot controller, and once it's uploaded there, you can execute it as any other normal program. Now, we need to take a look at some other things. Let's delete the robot machining project, the part of the program, and the tool. Let's go back to FeatureCAM. As I just deleted the part from my station, I can use this option here to import it back to RoboDK. Before doing so, let's open the settings to give the part a name. So let's go for a simple wall panel. Click OK and press load part. Now, if we go back to RoboDK, and it can take a few seconds to load obviously, we can see that the part was imported at the right position. We could have done that the first time, but for the sake of keeping things clear, I thought it was better to already have the part in place. Okay, let's go back to FeatureCAM. Let's select both milling processes this time. So like I told you before, you can avoid recalculating all the paths again in FeatureCAM, which can take some time depending on the size of the project. Now we can click Load and See Program once again. But this time I don't need to recalculate for the simulation. So let's press cancel. This won't cancel the export of the path, just cancel the simulation in FeatureCAM. In this case, we should expect to have 3 programs in RoboDK. The one we imported before, so the surface milling, the roughing program for the general shapes, and the finishing program for the general shapes. Okay, perfect. Let's switch back to RoboDK, and there it is. Let's make sure that we are close enough and centered. Okay. It's kind of a mess right now because of all the normals we see on the screen. I'm going to get rid of those in the same way I showed you before. So right click and visible normals. Let's do that for all the programs. There is still a lot of lines, but it's better this way, I think. If you click on the robot machining project, you can see that the path linked with that project will become cyan blue. So that will help you identify which program is which program. You can also see that this time 3 tools were created, one for each milling process. As you can see, it also created a main program including the 3 machining projects. They are in the same order as in FeatureCAM, but you can reorder them if needed. The green check marks here show that all those programs are updated and feasible. Therefore, I can simply run the main program. If you are satisfied with the result, you can generate all the machining programs and load them on your robot controller. Okay, that's enough information for this first FeatureCAM tutorial. In the next one, we will explore 5-axis machining. We will also take a deeper look at the robot machining project parameters as we barely scratched the surface this time. And, as I said, we will also need to talk about the automatically generated tools, as the tool definition is a critical part of the process if you want to reach a great level of machining precision. If you have any technical questions, I invite you to visit our online forum at robodk.com/forum. I also recommend you to subscribe to our YouTube channel if you don't want to miss any new features. And if you think this video was helpful, I would appreciate if you could leave a like. Have a great day, guys.